Okay, let's take a look at transformations of exponential functions. So here's our exponential function, y equals some base to the x power. So let's go ahead and take a look at, let's make the base 10, for example. We could make the base 3, 4, 5. There's an infinite number of parent functions. So for my example, I'm going to go ahead and make the base 10. So y equals 10 to the x. So that would be the parent function for base 10 exponential functions. Now to get the parameters here, I'm going to rewrite this with parameters. So we'd have a times b to the x minus h plus k. Remember, your A is your vertical stretch or vertical compression. H is your translation left and right, and it's the opposite. And K is your translation up and down. Okay, now let's take a look at logarithmic. So for logarithmic functions, we have y equals the log base b of x. Okay, incorporating our parameters, we would have a times log base b x minus h in parentheses, that's your left and right, plus k on the outside. So normally we like to use base 10 because our calculators work in base 10. So if I was to make this base 10, it'd be just log of x. If it was base 3, we'd have to write y equals log base 3 of x. But when it's base 10, you don't have to put any number here. It's assumed to be base 10. Okay, so now let's go ahead and go to our worksheet. I hope you wrote these down. I do want you to write these down somewhere. So here we go. So here is our exponential function. Now when we transform it, we're going to move this point here. You know, when we did quadratic, we moved the vertex. Well, this is the point that we're going to translate, the point 0, 1. Okay, so color number 1. I'm going to use purple. All right, so we have f of x equals 10 to the x plus 3. Do you remember what this does to the function? That's right, this is a translation of 3 units to the left. So we're going to take this point right here and we're going to go 1, 2, 3. So that's the new point for here. Now all we do is notice how we come down and along the x-axis. Same thing here, come down along the x-axis. And it's just going to rise very quickly on the other side. So that is that function. We translated 3 units to the left. Our asymptote equation, our asymptote did not change, so it's going to be y equals 0. All right, switching colors. All right, this time our k value is different. Okay, so this says we're going to take this function here and we're going to move it, that's right, up 3 units. So we're going to go 1, 2, 3. Okay, now to graph it, notice from the original we go down and curve over. So from here we're going to go down and curve over and then rise quickly on the other side. So notice our horizontal asymptote is different. is different. What is this equation right here? Y equals 3. Okay, make the connection. On this one, the horizontal asymptote did not change, but on this one, it did. Okay? Okay, third color. Oops. Back here, orange, red. This says 3 units to the left, 3 units up. So starting from our parent, 3 to the left, 3 up. So that's going to be our point. So again, following the basic form of the parent, we're going to go down and over, and then you're going to rise quickly. So the horizontal asymptote here is going to be y equals 3. So here's the question. Is it the h value or the k value that affects the horizontal asymptote? H or k? Okay? So I want one of these circled tomorrow when I'm checking. Okay, let's take a look at number 2. So here we have a logarithmic function. And the point that we're going to translate is 1, 0. So for purple, this says to go 4 units to the left. So 1, 2, 3, 4. 4 to the left. And notice it goes over, it curves over and down along the asymptote. So the same thing's going to occur here from this point. It's going to curve over and down along the what? That's right, the asymptote. Okay, and notice here it curves up. Now it's actually going to continue to curve up. So it's going to curve over. It's just going to keep rising very gradually. It's going to keep rising very gradually. It's going to keep rising infinitely. Okay, so we're going to have our new asymptote right here. So the equation of this asymptote, x equals, that's right, good job, -4. Okay, next color, how are we doing? We're 8 minutes into this video, we're doing good. Color 2, orange. Alright, this tells us to move 4 units. Notice it's not in the parentheses, so it's going to be 4 units up. So from our parent, 1, 2, 3, 4. Alright, curving it down along the asymptote and curving it up. Alright, and this is going to continue to rise very gradually, but it will continue to rise. Here, the asymptote is x equals 0. Okay, last color, red. Lindsay, I hope you're enjoying all these pretty colors today. We're going to go 4 to the left and 4 up. So 1, 2, 3, 4. 1, 2, 3, 4. Curve down along the asymptote. Curve up. I probably curved that a little bit too much there. It's going up very gradually. And asymptote x equals -4. All right, now this is logarithmic, this is exponential. What affects the asymptote here, h or k? What do you think? Now, for tomorrow, when I come around, I'm going to be looking for whatever you circled here, and I would like you to do these 2 problems on the bottom on your own. All right, we're at 10 minutes, so we're going to stop here. See you tomorrow.